So perfect. Yeah, I'm a scientist in the hematology lab in Kiel, and first I would like to show you where you can find the SOPs, as there was a lot of work made in the last decades to prepare all those protocols so that everybody
presentation mode, please.
Okay, sorry. For me it looks different, sorry.
Okay.
Where do I? Now it's better?
Yeah, full screen.
Okay, okay, perfect. So
Yes.
again, exactly. So this SOPs you can find on the EuroFlow webpage. You need to register, log in, and then you can simply download them. Under the topic of this protocols, you can find not only the protocols for the sample preparation and instrument setup, so there are also further interesting things you can have a look at, for example, on the different panels we have, and also maybe some, if you use, for example, the lyric, you can download other things you need for your instrument setup. We have some videos, for example, for the bulk lysis SOP and also for the instrument setup, which you can simply watch. So I also would like you to pay attention and have a look from time to time on the homepage whether there's a new version released, for example. So we have some SOPs which are freshly updated. And first, we have a look on the sample preparation SOP. So in this new version, you always have a short bullet points, what was updated or corrected. You always have a content of the SOP, so what you can find here. And for your stainings, I think it's always important to know which panel would you like to stain, and then you can find which part of the SOP is most important for you and the panel you would like to apply. So for example, if you want to stain samples with a surface membrane immunoglobulin staining, it's always important to read everything very carefully. For example, in this specific point, it is important to wash the sample 3 times. So, and why is this important? So this picture was given to me by a EuroFlow lab, and they made a very nice comparison. So how many washes of a sample has an impact on the staining of the light chains. So you see that from 1 wash to second, third, fourth, and so on washes, you get most separation of the stainings on the B cells for the kappa and lambda light chains. So, however, what is the theory and the practice? Maybe most of you also have experienced that we get the good separation, the somehow separated samples, and the samples where we are not so sure whether there is any separation or all the cells might be kappa restricted. So if you doubt whether your separation is good enough, so here are some troubleshooting points. So either, as I have shown, maybe another washing step can also help. Maybe have a look whether the correct washing buffer was used. So for example, was the pH okay, or was the BSA included, and so on. But there can also be patient-specific circumstances, for example, if you have like patients with a huge amount of free light chains, sometimes it's almost impossible to get very good separation. So there are also other panels where, for example, in the TCLPD, cytoplasmic staining of antigens, here the granzyme B, we updated this. So here also we get a better staining if we add another washing step for the after the intracellular antibody staining. So this is also new. So always have a look on the most recent version. And for those of you who are doing the MRD panels, for example, they use the bulk lysis protocol. And there has been a publication by Juan Flores Montero where we tested all the different possible variations on how you can use the bulk lysis, so different compositions of the reagents. And I think in the end, it turned out that the protocol with this 0.5% BSA and using the FAX lyse step is the most efficient one with the less debris and containing the high number of cells which you can acquire, and also containing the cells of interest, for example. So this protocol can be used with bone marrow or peripheral blood samples. And the lysing solution, you can either find a recipe in the EuroFlow SOP for an in-house ammonium chloride solution. However, here are maybe some important points. So make sure that you have followed really the recipe for the preparation. Control the pH if needed. So maybe it's good to check it the next day, for example. And also be sure that the solution is freshly prepared, so it should not be older than 7 days. However, if you are doing a lot of MRDs, I think they are not getting so old. So there are also two commercial possibilities. So BD farm lyse and the cytognos bulk lysis, they differ a bit in their composition. So maybe you can also try both of them. And from yesterday's discussions in the breakout room, I also included a point troubleshooting. So some people might have, and we also have those problems from time to time. So the input versus the output cells. And so we say that you should start with a minimum of 10 times 10 to the 6 cells. However, some samples are very prone to cell loss, and I would say that the recovery should be above 50% of input, and even better maybe. So I think it can be, I don't know, what tubes do you use? So some cells tend to not to form a good pellet on some plastics. So make sure that maybe the plastic is fine for the cell pellet formation. And maybe you can also have a look. So how do you really remove the supernatant? So do you decant or aspirate manually, like in the video? Do you use a pump, for example? So everything can be important where you can lose cells. And also, sometimes we have the problem that we don't have a reliable initial cell concentration. For example, some automated counters or hemocytometers, they are not able, for example, to count good on bone marrow samples, or you have maybe a very high leukocyte concentration and the hemocytometer is only valid until 100,000 cells per microliter, for example. So this can all impact your input versus output in the bulk lysis protocol. There are also, for the instrument setup, you have different versions included on the webpage. So for example, if you use the DSX flags, the Lyric, LSR, or Navios, so the different companies are all here. And I also included from the yesterday's discussion some points for troubleshooting on the compensation. So for example, with the instrument setup, I think it's always important to use a really fresh Cs and T beads, or if you use other than the BD machines, just the QC beads. So don't use them in the afternoon if they are prepared in the morning. I think this is also very important. We also produced very weird compensation results when we used old CSNT beads. So make sure they are fresh. The compensation controls, it's also sometimes interesting how it is different between beads and cells. So the intensity can be different, the autofluorescence, and it's also interesting to check your acquired control. So for some machines, it's possible to see it directly. For example, for the Lyric, ask your technician or your service engineer where you can find the FCS file. It's saved in the machine or on the in the software, so you can have a look how good it was. And for example, if you have an intensity on beads, but the intensity on cells is higher, you always get this compensation problems. Although it's stated that compensation should be linear, I think we all know that this is not always the truth. And also for the different fluorochromes, it's important to know that although they have, for example, a very similar emission spectra, they are not the same. So you really need to make specific compensations for the different dyes, and especially the tandem dyes need lot-specific compensation. Every time you get a new lot, you have to refresh the compensation or add the compensation to the machine. And sometimes we also face the problem of, especially for the tandem dyes, the fluorochrome degradation. So it's also interesting to maybe monitor if you use the tandem dye very long, that you make sure that it's not degraded. And this was also sometimes you see this spread. For example, this is an example of the LST. So if you have a high PE signal, you get a high compensation spread in the per-CP channel. This is normal. This is nothing, you did not do something wrong. And I think if you see that if the PE signal is like a log lower, this spread is almost absent. So this is not your fault. It's just a simple problem of the compensation. So yeah, this is what I meant. This can be depend on the median fluorescence intensity. Some cytometers maybe have better filter combinations, and then the spread might also be not so obvious. So take-home message from my side would be read the SOPs carefully because some stainings are special. Some problems can be sample dependent and you cannot do so much about it. And for the compensation, use the right control. This can be beads or cells. The tandem dyes need definitely lot-specific compensation. We see it every time. And I think the most important thing is you are not the only one having issues in flow cytometry. So please ask questions. So ask other labs you know or contact a flow cytometry community. I think this is what you did now. And I'm happy to take questions later in the breakout room or write me an email. So thank you.